Sine of theta is equal to 1/2. Let's say I wanted to solve. Set. What's the variable in this problem? Theta. So I'm trying to find an angle. Hudson, how do I solve a trig equation for the angle? Yeah, you do. We did this way back in 12.1. Inverse trig. If I've got sine of theta as 1/2, I take sine inverse of both sides. I get theta as 30 degrees. Quinn! What if I wanted that angle in radians?
Times it by 180 over pi.
We would multiply by pi over 180. We would get pi over 6. Or, since 30 degrees is on our unit circle, we could have looked at our unit circle and said 30 degrees is equivalent to pi over 6. Change the instructions. This time I want to solve for all theta between 0 and 360 degrees. Between 0 and 360, what sheet of paper do you think you maybe should have on your desk right now? Harmony. For what angles between 0 and 360 does this work? For what angles between 0 and 360 is sine 1/2? That's one of them. Good. And 150 degrees. Beautiful. Changing the instructions on you again. Instead, we're going to solve for angles between 0 and 2 pi. Spencer, what do we get? Yep, look in the unit circle. Where is sine 1/2?
Pi over 6.
Good, that's one of them. Where else? 5 pi over 6. I'm going to change the instructions for you again. Solve for all theta in degrees. Najma, how many answers am I looking for? 2 are on the unit circle, but how many are there total? An infinite number of answers. I'm looking for an infinite number of answers here. Because if I'm looking in degrees, on the unit circle, we've got 30 and 150. We established that earlier here. How do I transition that to all angles in degrees? Let's start with this. If I know 30 and 150 work, what are some other angles that would work? I could add and subtract 360. I could do the coterminal angles. I can add and subtract 360 as many times as I want. And those angles will work. So, theta equals 30 plus, not just 360, 360 what? K, where K is an integer. That takes care of every multiple of 360, positive or negative, which will take care of the minus. That's half of my infinity. What's the other half? No. K takes care of integers. It takes care of the minus. The 150 plus 360K, where K is an integer. Back in chapter 12, we did some solving of trig. We started solving trig like back in 12.1. We did inverse trig, and then we got to 12.9 and started to say, well, what if I don't just want an angle, but I want an angle in both degrees and radians? Or what if I don't just want a single angle, I want all angles on the unit circle? 13.5 brings this back, but it changes the equations. In chapter 12, the equations looked like this. In chapter 13, they start to get a little more complex. They get complex in a way where you might have to use some trig identities to work in your favor. Or you might have to take into account that these trig equations might not just be sine equals a number or any of the ones. It might have sine squared involved. It might have both sine and cosine involved. And so, in 13.5, we start to get to all the different ways we can manipulate equations to get it to this point where I could start using either my unit circle or my calculator to solve. Now, we tend to use our unit circle for this, and it tends to be the easiest way to go, but in all technicality, there's also a relationship between the first and the second angle, the 30 and the 150, that is true for sine and cosine and tangent. And to be clear, it's actually different relationships. I didn't clarify that well enough. When you're looking at sine, if you're trying to solve for sine, you could do inverse trig, and that'll get you your first angle. Sine inverse of 1/2 would have given us the 30-degree angle. But if I want the 150-degree angle, the way that it works for sine is sine angles that have the same result are supplementary. You guys remember what supplementary means? Add up to 180. So, if you want to work with sine, 180 degrees minus the angle from the calculator will get you the second angle, assuming it's in degrees. Cosine angles are different. Cosine relationship between angles for cosine to have the same result, it would be like a 30 and a 330 degree angle. Both have square root of 3 over 2. Or a 60 and a 300. Or a 120 and a 240. Both have the same thing for cosine. Do you notice the relationship in these pairs? 120, 240, 60, 300, 330, 300, 30 and 330. What do they add up to? 360. There's not a term for that. So you take 360 minus the angle from the calculator, and that'll get you the second angle. Tangent. Tangent is the same at things like 30 and 210, 45 and 225, 60 and 240, 90 and 270, 120 and 300. Do you notice they're directly across the circle?
Yep.
They're half a circle away from one another. How do you travel half a circle? 180 degrees. These ones differ by 180 degrees. In other words, you take 180 and add it to the angle from the calculator. And that can get you from one angle to the next angle for tangent. Now, this being said, you can always use your unit circle. I tend to find that to be easiest. And then don't forget about coterminals. I tend to use the unit circle mainly because my calculator, if you do inverse trig, will not always give me angles on the unit circle because of the range of inverse trig. Sine and tangent will give me angles that go all the way down to negative 90. So I tend to use the unit circle. Now, today we're going to start solving slightly more complex equations. We're not going to use the identities today. We'll bring up the identities next week in our solving. But today I want you to start seeing some of the more complex equations you're going to look at. So we're going to solve the following for the given range. Some of them are just going to be slightly more complex. 2 sine of theta plus square root of 3 is equal to 0. Now, in all actuality, a problem like this one, I probably could have given it to you back in chapter 12 and you would have been just fine. Because if I want to use inverse trig, to solve for theta, because that's my variable here, I have to start by getting the sine alone. Where should I start? Subtract square root of 3. Two sine of theta is equal to a negative square root of 3. Is sine alone? No. How do I get rid of the 2? Divide by 2. Sine of theta is equal to a negative square root of 3 over 2. Is sine alone? Yes, now it's alone. My options are to do inverse trig and find the angles that I want within the range, or what do you notice about that range? Isn't it just the entire unit circle? So it's easier probably to use the unit circle. I'm looking for where sine of theta is equal to negative square root of 3 over 2. So I'm looking at my unit circle, and sine is what part of the unit circle? The y values. So I'm looking at the y values and finding the y values that are negative square root of 3 over 2, and I'm finding the angle in radians. Where is sine a negative square root of 3 over 2? 4 pi over 3 and 5 pi over 3. Done. That's all the angles in the proper range. So far, not too scary. Still more complex than what we did back in chapter 12. They do get more complex than that, but tangent of theta plus 1 is equal to tangent of theta for all theta in radians. Now some of y'all are looking at this probably being like, what the heck is going on? If you ever are looking at these problems as if it is a struggle to kind of figure out what to do with it, if the angle is the same and it's a single trig ratio, are the angles all just regular theta here? Yes. Yes, it is a different schedule. Rude. Anyway, all the angles are theta. Is it the same trig ratio throughout the problem? It's all tangent, right? If it's a struggle bus to look at, you always can change it to a variable if it makes it easier to start. Only helps you get the first part of the problem done, and it only works if the things you're replacing are the exact same. If I was to change this to an x, do you know exactly how to solve that? What do I start with? I personally wouldn't subtract the 1. You can't divide by 2 yet. I would have subtracted 2x. 1 equals negative x. Divide by negative 1. X is negative 1. Now, if you do it this way, you just have to remind yourself that you were never solving for x. What did x replace? Tangent. Tangent of theta is negative 1. You also have to remind yourself that you actually weren't solving for tangent either. What are you solving for? Theta. In what units? Radians. I want all theta in radians. When it goes for all theta in either radians or degrees, just start with the ones on your unit circle. on our unit circle, tangent is -1 at what angles? In radians. 3 pi over 4 and 7 pi over 4. Those give you the starting ones. The ones that are not on your unit circle are always coterminal to them. So plus, make sure you're working in radians. A full circle in radians is 2 pi k, where k is an integer. That being said, this doesn't have to be your final answer. Sometimes when you're solving for this, answers can be simplified. They can be simplified in situations where the answers are a certain distance apart at all times. Tangent earlier, weren't the tangent ones always the same distance apart from one another? Half a circle? If they're always half a circle apart, this can be simplified down. Now, I am okay if you give this as your answer. This is a perfectly acceptable answer. I'm not going to get overly finicky about you simplifying it down. But you will see situations where it gets simplified down. And if they're all half a circle apart, then I can start with one of these angles, doesn't matter which one, and instead of adding a full circle, add a half circle, and that'll take care of getting both from 3 pi over 4 to 7 pi over 4, and then back to this one's coterminals and to this one's coterminals. Did you have a question? Yes. If you notice I can simplify down, you are welcome to do so. Do you have to simplify it down? No. I'm not going to get overly finicky. Okay? They get a little more complex than that still. Some of the problems are not going to are not going to solve as simple as getting the trig equal to a number. Because I have both cosine squareds and cosines, I can't do that. This is where sometimes changing it over to x's makes it easier to see what you can do with it. Again, that's not a required thing. If you don't like changing it to x's, if you prefer just leaving it as cosines, leave it as cosines. I am allowed to change it to a variable to look at if it's the same trig ratio and that trig ratio is to the same angle. Is that true in this case? Yes. Which means I can solve this as, instead of cosine squared, x squared minus 2 equals, instead of negative cosine, negative x. What type of equation is this? It's not linear, it's quadratic. You want to solve quadratic equations, you start by getting them equal to 0. X squared plus x minus 2 equals 0. After that, you've got a couple of options. You can use square roots to solve if you don't have both x squareds and x's. That doesn't apply here. You can do things like completing the square, which no one tends to like. You could do quadratic formula, or you can factor. I personally prefer factoring. Are there two things that multiply to -2 but add to 1? 2 and negative 1. Shortcut to the AC method. X plus 2x minus 1. Still equal to 0. What is the only way things multiply together and give you 0? Is if there's a 0 you're multiplying by. It's known as the zero product property, which means if this times this is equal to 0, then that means either this x plus 2 is equal to 0 or this x minus 1 is equal to 0. You split your factors and you solve them individually. X is equal to negative 2 and x is equal to 1. But were you solving for x? What did x replace? Cosine. Cosine of theta is equal to negative 2. Cosine of theta is equal to 1. But were you solve? Enjoy your lunch. We got cosine is equal to negative 2 and cosine is equal to 1. But were we trying to solve for cosine?
No.
No. We're trying to solve for theta. Grace, where is cosine equal to negative 2? Don't overthink it. Anywhere? Because cosine never gets to negative 2. Cosine's amplitude is 1. Highest it goes is 1 and negative 1. Malia, where is cosine equal to 1? 0 and 360 degrees. And be careful not to miss one of those when the range is that. Okay, got just a couple more examples for you. You won't be able to solve either of these.
I bet we could.
Okay, the first one, I am incorrect. I looked at the first one wrong. You probably wouldn't be able to solve the second one.
How many more of those M's are meaning two?
That's why I said we're all.
Okay, hotshot, how do you solve it?
Oh no. I'm not involved in this. Oh, you gotta divide by cosine. On the right.
Got to do it to the left side or two, right?
Yep. Boom.
You're not done. Where are you getting 180 from? Okay. What about the rest of the answers? Mm-hmm. No, I'm not. I'm not joking. There's more answers to this.
Oh, we have to find.
We have to find cosine too.
Right. You guys, let's find cosine.
Okay, what's cosine equal to?
Because we found
There's two. That's like an extra one.
Yeah, you guys got it.
Okay, so how about I take over?
It's
Okay, yeah.
cotangent.
Okay, so ones like this have something about them that's a little bit different. Yes, you can divide by cosine, but if you divide by cosine, you've just eliminated half of your answers. So, causes a problem. This is an option, though. It really is. You just have to keep something in mind. That when you divide by cosine, cosine is not allowed to be equal to what? 0, because you cannot divide by cosine if cosine is 0. Now, if cosine is equal to 0, would this equation also be true? If cosine is 0, this becomes sine times 0. What's sine times 0? 0. This side becomes a negative 1/2 times 0. You get 0 equals 0. So if you're going to divide by cosine, you also have to take into account the situation where it is 0. If you're going to divide by one of the trig ratios in order to solve, you also have to set that trig ratio equal to 0 for the alternative situation where you weren't allowed to do that. Which means theta is equal to 90 plus 360k, where k is an integer. And theta is equal to 270 plus 360k, where k is an integer, is also a set of solutions. Yes, these two solutions could be simplified down because they're half a circle apart. So you can either have all 4 of these as your answer, or those two and theta equals 90 plus 180k, where k is an integer. I do still have my other example, the one that honestly you probably could have solved because of the fact that it does include a common error that I want to address. Oops, that was supposed to be a 3. Tangent squared theta is equal to 1/3. Use the square root. When you square root, what do you need to include?
Plus or minus.
Positive or negative. Far too often people are forgetting that. How do I square root 1/3? Top and bottom. Square root of 1 is 1, square root of 3 is square root of 3, and rationalize your denominator. And you get square root of 3/3. But remember, oops. Wait, no, I did that right. Remember, tangent was never what you were actually solving for, so go to your unit circle, find where tangent is square root of 3/3 and a negative square root of 3/3. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Before you are done, always check to make sure you've answered in the correct units and that you have all of the answers at once. Yes and yes in this case. Got a worksheet for y'all.